this next group of problems, we're going to look at what's called a composition of functions, which looks a little bit different. You should have seen this before in college algebra because that's a prereq to this course. But let's go ahead and go through a reminder. Is composition of functions looks like this, where it's read G with a little circle, F, and then we've got parentheses that are around that, and then we've got another set of parentheses around an X. Or what other notation, which means the same thing, will be a G with only parentheses around an F of X. Either way, these two notations can be used interchangeably. However, I tend to dislike the first notation, the circle notation. Why? Because most students misread that and think it's multiplication. This is not multiplication. This is a composition of functions. And what a composition of functions means, I'm putting one function inside of another. So it's one function getting plugged into another. That's why you also see it written as parentheses. So generally speaking, what I'll do is I always tend to turn the notation with the circle into the other notation, just for ease, because it makes more sense. So what does this mean we're going to do? It means we're going to be taking functions and plugging them into functions wherever there's an X. So the idea is to start from the inside and taking on these first few is taking what's inside, the F of X, and plugging it into the outside function, the G of X, wherever there's an X. And I love this notation with the parentheses because then it reminds you that when you plug in your F of X to plug it in with parentheses around it. So generally what I do is when I see the circle notation, I just go ahead and insert a set of parentheses instead, so that it looks more like the parentheses notation because they do mean the same thing. I can swap them out. So we'd start by reading our G with our circle F and our X. This is sometimes called Goff because you see the little circle looks like an O, which is equivalent to G with your parentheses F of X. So we would start by reading this by starting by mentioning our G, which is the first thing that we see if we read this from left to right. Then we would start out with our little circle thingy or parentheses, which is read as of. And then we'd go after our next function, which is your F. Well, we'd start out with our F, and then we see another set of parentheses after that, which is another of. And then we see our last part, which is our X. So we'd go ahead and mention our X. So how this is read, if you were to kind of read it as a sentence, is G of F of X. So it's kind of like leapfrog. What it's telling you is to work from your inside out. So you start with 1, your X gets plugged into your F. Then whatever you get out there then gets plugged into your G. So what that kind of looks like in a linear form means you're going to start out with your X. If that's an actual number, you'll plug it into F. And then whatever you get out from there, and then whatever you get out from there by plugging that into F, will then turn around whatever we get out. That'll be something new here. Will then turn around and get plugged into our last part, the G. And then whatever we get out at the very end here is going to be our final answer. Now, if we're actually just left with an X and not a number for X, then we will get an answer that has X's in it. If we're actually given a number for X, then we'll actually get a number as our final answer. So the other thing that we're going to want to do is also be able to, we're going to have a bunch of these with X's in them, so we also need to be able to find the domain of these functions. So let's take a look at how you find the domain as functions and go over a quick review or recap of this. So finding the domain, we're going to start out with this easily. We will expand on this, but we're only going to start out with how you looked at this when you were doing this in college algebra, which is the main thing that you're worried about when you're finding the domain of functions is you're worried about what can we plug in for x? Well, with regards to regular functions, we run into really two big mathematical no-nos, which is normal functions. And one of the big issues is when we have an even root. When we have an even root, meaning a square root, a fourth root, a sixth root, and why are we calling them even? Why we're calling them even is because of the type of root. It's a fourth root, a sixth root, or if it's a square root, there's a hidden 2 there. And what we're worried about with roots is that we don't want to end up with imaginary numbers. What gives us imaginary numbers are negatives inside of an even root. So what we want to make sure happens when we have an even root is that whatever's inside of the root, ends up being greater than or equal to 0. By saying that we want it to be greater than or equal to 0, we're making sure we get something that is not negative, so that we don't end up with i's. However, there will be no similar rule for odd roots. Why? Because we could take an odd root of a positive number or a negative number, but that, like I said, is not true for even roots because you end up with imaginaries or i's. Let's talk about the next thing that we want to talk about. The other big mathematical no-no is that if you have a fraction. What's the problem with a fraction? Well, remember the problem with a fraction is you cannot divide by 0, which means that the denominator, when you've got a fraction, which is the bottom part, the denominator cannot be equal to 0. We don't care about the top. We just care that the bottom, the denominator, cannot be equal to 0. So those are our two main problems that we're going to be looking for when we are talking about finding the domain. Is worried, first of all, if we have an even root, or second of all, if we have a fraction. And the fact that if we have a fraction, we're worried about whether or not this denominator can equal 0. Otherwise, for right now anyways, if I have no issues, and by no issues, I mean, at least for right now, no issues that fit into case 1 or case 2 above, then what we'll say is our domain will be negative infinity to infinity. And that's a fancy way of basically saying that I can plug in any value I want. So what this means, the negative infinity to infinity, means you can plug in anything for x. Notice we're not mentioning range. We're doing that on purpose. It's very hard to kind of predict what you can get out of a function. However, it's not so bad to determine what you can plug into a function, so that's why we're mainly going to always look at domain and not range. So let's take a look at a couple of functions.